today we will discuss the formulas for center of gravity of one-dimensional elements, means linear wires. Okay, and we will check the master method of the numericals also. So I will take just one numerical today and I will show you how the center of gravity, coordinates of center of gravity will be calculated. Let's see. Okay students, so today we will discuss the formulas of center of gravity for one-dimensional elements. One-dimensional elements means what? Means wires, means lengths. Suppose a straight line is known as one-dimensional element. Suppose a circular arc is known as one-dimensional element. Suppose a semicircular arc is known as one-dimensional element. Suppose a quarter circular arc is known as one-dimensional element. So it is not a closed figure, it is only open figure, means having two endpoints, is known as arc or wires. So how will you check that the given figure is one dimensional or two dimensional? It is not so easy. Let me show you. Suppose it is given that this is a circle. Then how will you know that this is a circular arc or circle? See, circular arc and circle both are different things. Circular arc means a wire which is bent in the shape of circle, while the circle is an area 2D element. In the simple language, I can say that if it is a circle, then it is a solid part. Inside part is solid like this. Suppose it is not a transparent part. But if it is a circular arc, then it will be looking like this only. Means you can imagine that an air can pass through this circle. An air can pass through this circle. An air cannot pass through this circle. So this is area and this is length. Okay, so it is the difference between area and length. So today we are discussing about just lengths, means wires, one-dimensional elements. So we will check 4 formulas and one example today. Okay, let us see. This is the part 1. First one is geometrical shape, means figure is given to you, its length is given to you. Then after is x coordinate and y coordinate will be given to you, as we have discussed in the previous lecture. In the first figure, it is a straight wire AB, means straight line AB. From A to B, it is a straight line. I have already told you, if the length of the line is L, then center of gravity is at midpoint. So this portion is L by 2 and this portion is also L by 2. So its length is L, its center of length is L by 2, looking from the x direction or looking from the y direction. Means if you are taking horizontal line, then center of gravity will be at this point G. So this distance is L by 2. While drawing axis, so y-axis is over here. So from y-axis up to this point is known as x coordinate, x bar, which is equal to L by 2. Now in the case number 2, if the line is vertical, then center of gravity is at this point J. The distance up to this point is L by 2. If you are drawing x-axis from the bottom like this, then from this x-axis up to the CG, this distance is known as y bar. Okay, which is also equal to L by 2 in this case. Clear? So this is the part number 1, line. So this is how you have to calculate x bar, means x coordinate, and y bar means y coordinate. Let us see next part. The part is circle. You can see this is the circular ring, means wire ring. Circular ring, in the circular ring, the center of gravity is itself a center of the circle G. You can see its length is 2 pi r, means circumference. So length of the circle it means circumference is equal to 2 pi r. Now x coordinate of CG is r and y coordinate of CG is also r, means center of gravity is equal to center of circle r. Let us see how to draw x and y axis. So always from the bottom of the circle you have to draw x axis, and from the left side of the circle you have to draw y axis, means x and y axis are tangent to the circles. Now from this axis you have to check perpendicular distance up to the CG, up to the center of the circle. So let me show you, if from y-axis you are going up to the circle, center of the circle like this, then this distance will be r. So it is known as horizontal x coordinate r. Similarly, if you are starting from x-axis, from the bottom, and going up to this circle, means it is the vertical distance y bar, which is also equal to radius of the circle. So here it is x bar equal to radius, y bar is also equal to radius. So these are the coordinates of circle, center of the circle, x bar and y bar. So for the first and second part, line and circle, this is very easy, but in the third part it is quite complicated. Must listen, this part is very important. It is a semicircular wire AB, for which length will be halved of the circle, means pi r. In the circle the length is 2 pi r, in the semicircle the length is pi r. Now this is the x coordinate and this is the y coordinate of the CG. This is the fixed formula actually, 2r by pi, which we will derive by the integration method as I told you afterwards. Okay, so don't worry about this. As of now, just remember this formula, 2r by pi. Let me show you how it comes afterwards with the help of integration. Okay, just remember 2r by pi. Now where is the 2r by pi actually? If you draw an x-axis from the bottom of the semicircle and y-axis from the left side of the semicircle, then here is the center of gravity. You can see here is the center of gravity. So by finding the distance from y-axis and x-axis, this is the horizontal distance up to CG, then it will be equal to radius r. So x coordinate is r. But for the same CG, if you are finding the vertical distance y, then it will be 2r by pi. It is the fixed formula. You have to remember 2r by pi. So these are the coordinates for the semicircle, 2r by pi. But this is for the semicircle in this position only. Okay, if the semicircle arc is in this position, then x-axis at the bottom and y-axis at the left end. But what happens if semicircle changes the position? Let me show you. If this is the semicircular arc now, then where is the CG? CG will be over here, and from the radius line, from this radius line, this distance up to the CG will be 2r by pi. Okay, so now you will get what is 2r by pi. It is the distance from the center, from the drawing center of the semicircle to the center of gravity G. So this distance is known as 2r by pi. But now in this case, where is the axis? So let me show you. From the bottom you must have to draw x-axis, and from the left side of the semicircle you have to draw y-axis. Now what is our target? Our target is G, center of gravity. So from y-axis you have to find this distance. Okay, this distance. So it means what? This distance is known as x bar, which is equal to this distance, means radius of the semicircle. So x bar is equal to radius of the semicircle. So in this position x bar is not changing. It is same as this position and this position. But what is y bar? What is y bar? So it is the distance. Let me show you again. It is the distance from x-axis to this CG, So what is this blue color distance? Think about this. What is this blue color distance? This total distance is equal to radius of the circle, and this red color distance is equal to 2r by pi as per the formula. So what is this lower distance? This distance, it is equal to this radius minus this 2r by pi distance. So this lower distance will be r minus 2r by pi. So this is the formula for the y bar. Okay, so now this is the y bar, r minus 2r by pi. So according to the position of the semicircle, these formulas are changing, so you have to adjust yourself according to the position. As and when examples are coming in the next lecture, I will show you this again and again. Let us go ahead. This is the semicircle, then after this is the quarter circle arc. In the same manner, you have to find all the values. This is the quarter circular wire AB. The length will be pi r by 2. See, the length of the circle is 2 pi r. If it is semicircle arc, then it is half, means pi r. If it is quarter circle arc, then it is again half, means pi r by 2. What are the x coordinates and y coordinates? Both are 2r by pi in the formula manner. Okay, so you have to remember these two formulas. X bar also equal to 2r by pi, y bar also equal to 2r by pi. Let us see in the figure. In this figure, from the bottom you have to draw x-axis, and from the left side you have to draw y-axis. This is our arc AB, and inside that there is a point G, center of gravity. So center of gravity G is given to U. Now these two formulas are as per the position of the quarter circle arc. Now this is the generalized position, x bar and y bar. Now if I will draw the same arc on x and y axis, then see this. Suppose this is the quarter circular arc AB. This is the center of gravity G. Okay, this both the distances are radius. So this distance is known as x bar and this distance is known as y bar. So as of now, x bar is 2r by pi and y bar is also 2r by pi. So you have to remember the figure. Okay, these figures which I am drawing are only sketches, but according to the values you have to remember formula. It must be, this distance must be 2r by pi. Similarly, this vertical distance must be 2r by pi, means this distance is also 2r by pi and this distance. So you have to take the distance from origin to horizontal side 2r by pi and from origin to vertical side also 2r by pi. Okay, like that. So this distances, you will be cleared about this distances by practice only. So just do the practice, check your textbook also, you will get the same formula. So these four parts are important for us. Now let us take one numerical. Say this. What is the numerical? These are the examples on composite linear elements. Composite means more than 1, 2, 3, like that. So more than two parts are combined together and they are forming composite linear elements. Let us see example number 1. What is given to you? Find centroid, means center of gravity G, means find x bar and find y bar of the wire ABCD shown in figure. Wire ABCD shown in figure. As of now, you just forget this x and y axis. This dotted x and y axis you just neglected. What is the main figure? Starting from point A, B, C, D. A, B, C, D. So this is the composite element. So in this composite element there are three parts. First part is AB, second part is BC and third part is CD. So these three lines are composite lines. Now here it is given the reference axis, means at this reference axis you have to draw axis. First of all, check the lengths. What are the lengths given to you? AB length 20 cm, BC length 15 cm and CD length 10 cm. Now let us start with the axis first. So from the bottom draw an x-axis, and from the left side draw an y-axis. Okay, so this is the axis. Now you have to go part wise. What is the first part? First part is AB. So in AB, midpoint is the CG, like this. So you have to calculate coordinate of this CG, means for part 1. So from A to G, this distance will be half of 20. Why 20? Because the length is 20 of the line AB. So this distance will be 10 centimeter. This is horizontal distance, so it is known as x1. Why it is x1? It is for the part 1, and x means horizontal coordinate of CG. Okay, remember this. What is y1? It is the vertical coordinate of the same CG. Vertical coordinate of the same CG, but this CG, this green color G, is resting on x-axis itself. So its vertical distance y1 will become 0. So this is the final answer for part 1. Again repeating, what is for final answer for part 1? x1 will be half of length, means 10 centimeter, and y1 will be total distance 0 from x-axis. Okay, let us see again. For the part 2, length BC is 15 centimeter. Where is the axis? Axis at the bottom and axis at the left side. So G will be at the midpoint of this length. So if you are calculating horizontal distance from y-axis, this distance will be 20. So for part 2, x2 will be 20, and up to this distance, vertical distance will be half of the 15, means 7.5. So it is y2. So you have to calculate like this. Repeat this method again and again. If you are taking part CD, then length will be 10 centimeter. It is the midpoint of CD. G, center of gravity of CD, is at the midpoint. You have to take coordinates x and y up to this point. So starting from y-axis up to this point. So it will be 20 plus half of 10 means 5. So 20 plus 5, 25. So it will be x3. Now if you are taking this distance, vertical distance, then it will be 15 centimeter, means directly y3 is equal to 15 centimeter. So this method is just depending on the practice. Let us see on the next page all the calculations. Okay, as I told you, these are the parts: part AB, part BC, part CD. Here you have to take three values always: L1 x1 y1, L2 x2 y2, L3 x3 y3. As many parts, as many values. For part 1, length is 20, length is 15, length is 10 for part 1, 2, 3 respectively. Now as per the calculation in the figure I have shown you, x1 y1 means CG of particular part 1, that is 10 centimeter horizontal and 0 centimeter vertical. For part 2, horizontal from the y-axis is 20 centimeter and vertical is 7.5 centimeter. You can go back and check in the figure. For part 3, x3 will be 20 plus 25, means 25 total centimeter. Y3 will be vertical 15 centimeter. You can check back in the figure. So these are the calculations for part 1, 2 and 3 respectively. Now these are the separate calculations, but we have to find composite CG, means combined CG of all the three lengths. So for that combined CG, the formula you have to remember is x bar and y bar. Both are similar type of formulas. X bar is equal to L1 x1 plus L2 x2 plus L3 x3 upon L1 plus L2 plus L3. Similarly, y bar equal to L1 y1 L plus L2 y2 plus L3 y3 upon L1 plus L2 plus L3. Where is these values? All these values are in this box itself. So L1 x1, this is L1 x1, L2 x2, L3 x3 divided by L1 plus L2 plus L3. So just by replacing all the values, you will calculate in your calculator and you will get x bar equal to 16.67 centimeter. Similarly, in the case of y bar, all these values can be replaced from this box into this formula, and by simplification you will get 5.83 centimeter. So these are the coordinates of final CG x bar y bar equal to horizontally 16.67 centimeter and vertically 5.83 centimeter. So this is the method to calculate the CG of the composite wire. We will show you much more examples are the method is depending on the practice of the examples, so you have to do much more examples for the mastery, you can say, on the center of gravity. So let us check next examples in some more lectures. Till then, goodbye students. Thank you. Do practice for this numerical again and again. Thanks.